Benzene, we drew it out, is really stable for two reasons. One, because of the conjugated double bonds. So what that means is that if I just drew just some arbitrary molecule here, right, and I drew in every other bond as a double bond. So I have double bond here, double bond here, double bond here. When you have double, single, then double, these double bonds can interact. They're considered conjugated. So what that in actuality looks like is this. So that these two electrons that make up this bond can now react with these two electrons to make up this bond. And it can now react with these two electrons that can make up this bond. So now you have 6. Sometimes they're called pi electrons, because they're made up of, they're part of these pi bonds or double bonds. And it's a result of, not to get too deep with this video, but it's a result of overlapping p orbitals. So that when you have a double, single, double, these electrons can react, and this is actually a more accurate picture of what this looks like here. So this provides, since these electrons now have more space to move around, this provides an extra degree of stability. The electrons, they love to have space, they love to move around, and when they do, they're not going to be as anxious to react with other molecules. Okay. So that's conjugation. And 2. Oh, and of course you have double, single, double, and so on. And that's also a reason why when you see benzene, you might see it written like, let's draw the other example of conjugated double bonds here. I see benzene written like that, because the double bonds that are conjugated, they're interacting. Again, this is a more accurate picture of what this benzene might look like. A lot of people, including myself, just draw just a circle like that to represent a dotted line. It's just easier. And these double bonds, this picture really isn't correct. These double bonds are not considered to have only partial double bond character, because since they're interacting, it's more like 1.5 bond. 1.5 bonds throughout. Actually, 1.5 continuous bond throughout this inside of the benzene ring. So conjugated double bonds, and another thing that makes benzene really stable is aromaticity. Aromaticity must obey, hope I'm spelling that right, Huckel's rule, maybe a C in there, which says that you need 4n plus 2 pi electrons. So in other words, inside the ring. I think this might be C, sorry about that. And n could just be any positive integer, 1, 2, 3, and so on. So the first aromatic ring that you can have would just be to plug in n1 for n. So you get 4 times 1, which is 4 plus 2 is 6. So do you have 6 pi electrons in here? Sure you do. You have 2, 4, 6. Is this aromatic? Yes, it's aromatic. Okay, so the next ring would obviously be 4 times 2, 8 plus 2, that's 10. So you have 10 pi electrons in the ring. So benzene's pretty stable, but there's some things that can make it. By stability. Let me just go over that. Stability means something's not very reactive, not reactive at all, even. Let's say you had lots of heat to it or something like that.